Hello everyone and welcome to day 26 of the Jamb Physics in 40 Days series. I want to say a big thank you to each and every one of you that has been part of the series from day one. Thank you for being part of the series. Thank you for always liking the videos. Thank you for always sharing the content that we produce here on this channel. You are the real MVPs. Please, I would like to encourage you that you do not stop. Please continue to like the videos, continue to share them. We want to ensure that we reach a wide range of audience that really need helpful content like this. So please keep helping us by sharing the videos and liking the videos as we continue to give you helpful content like this. To those of you who are new to the channel, this is Oya Learn, and this series is Jamb Physics in 40 Days, brought to you by Oya Learn, of course, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you should be able to equip yourself properly to ace Jamb Physics. So in case you are preparing for the Jamb exam and physics is one of the subjects you have chosen to write in that exam, then this video is specially made for you. So trust me, you do not want to miss any of the videos in the series from day one till the end of the series. What we have done is that in each of those videos, we have looked at individual topics in the Jamb Physics curriculum, and then we go on to give you a crash course on the topics, tell you what is expected of you as a candidate taking the exam, while we solve past questions on those topics. And as we do so, we also give you tips that help you to solve such kind of questions with high accuracy. So if you want to ace your next Jamb Physics exam, then ensure that you follow this series from start to finish. And I would like to implore you to also ensure that you subscribe to the channel. Please hit the subscribe button and the notification bell icon so that every time we put out a new content, you will definitely be notified. And also don't forget to share the series so that we keep reaching more people who need videos like this. And I also like to encourage you that one of the things that make you a student that is very good is the length of practice you put into works like this. And to practice even better, there's an app called the Exam Fund app. The link to download it is going to be added to the description box. Please do well to click that link and download the app and improve your practice time. You know, one thing about that app that I love so much is that it infused a bit of fun into your learning time because the app is created like a game session where you solve different questions at different levels and then you earn points based on the number of questions that you answer correctly. So if you are the type that like to have fun while you learn and also earn as you learn as well, then that app is for you. Do well to click the link, download the app, and just enjoy yourself. And don't forget to share it amongst your friends also. Don't enjoy it all by yourself. Now let's get to the business of day 26, where we'll be looking at optical instruments. And what Jamb expects of every candidate is that when you are taking this exam, you should be familiar with these topics that I've highlighted here. You should be able to understand the principle of microscopes, telescopes, projectors, cameras, and the human eye. Should be able to tell how they function, the different parts that they are made of, and how those parts function to give the overall function of such optical instruments. Like in the case of telescopes that use convex lenses, in the case of projectors that has slides and the lens that would project the image onto the screen and things like that. You also understand cameras and the human eye. Now, one thing is that you see the camera and the human eye, they are very similar. They have also their differences, of course, from the fact that camera is a machine and the human eye is, of course, a biological material. So it has a biological makeup, so they are different in that. But there are so many things that they also have in common. And there are some parts of the camera that has its reciprocal in that of a like eye to camera, camera to eye. The same function that you have in that of the camera, you also have it in that part as a part of the eye. They have that similarity there. You should be able to tell what part of the camera functions like what part in the human eye and so on. And beyond that, you should also be able to solve problems on power of a lens. It is given as power equals 1 over f. where f is the focal length of the lens and it is measured in diopters. Now, one thing you should always keep in mind when solving problems like this is that when you are working with the focal length of the lens, you have to put it in the correct SI unit, which is in meters. Now, Jamb does something always where they give you questions like this and the focal length is given in centimeters. Do not forget to convert that into meters before you find the power of such a lens. Another thing is you should be able to understand the concept of angular magnification, and then you should also understand the near and far points of the human eye. A normal human eye, for example, will be able to focus images from distance of 25 centimeters to infinity. Now, the 25 centimeters is known as the near point, while the far point of a normal human eye is at infinity. Meaning, if you place an object between 0 and 25 centimeters, human eye will not be able to focus on it properly. But between the 25 centimeters to infinity, any object placed here would be focused correctly by the normal human eye. However, there are some eyes that have defects and as such makes it difficult for them to see some kind of object at some distance. Now, that takes us to sight defects and their corrections. So there are some sight defects such as the myopia, also known as the short-sightedness, the hypermetropia, known as the long-sightedness. Then we have other eye defects like the astigmatism and presbyopia. Now, for each of these sight defects, the corrective lenses for them are placed right beside them here. So for short-sightedness, you use the concave lens, and then for the long-sightedness known as hypermetropia, you use the convex lens to correct that. Then for those who have astigmatism, they are always prescribed with cylindrical lenses. And then for presbyopia, they use bifocal lenses. So you should be able to understand this concept and answer so many questions with this. Now, because this is a Jamb prep video, you see that we are not going so deep into all of these details. But if you really want more details to understand all these concepts in greater scale, please check out our video on optical instruments. Also on this channel, I promise you it is more loaded than what you see here. We've been able to explain each of these concepts in details, giving you examples as we go and tips also that help you understand it even better. And in some cases, we use real life situations to explain them so that they stick to you, so that whenever you hear them, you can easily understand what is being talked about there. So don't forget to check out the videos, and also don't forget to like them and also share those videos. Now, what we're going to do next is we're going to begin to solve some past questions on optical instruments, and then I'll be giving you some tips also that will help you to solve such questions with great accuracy each time you do them. So if you're ready, get your materials and let's solve some past questions. An astronomical telescope is said to be in normal adjustment when you're working with an astronomical telescope. To get normal adjustment, you have to ensure that the focal point of the objective lens and the eyepiece are at the same point. So when the objective lens and the eyepiece have focal points that coincides, what will happen is that the image formed is going to be at infinity. So that is, for normal adjustment to occur, the image has to be formed at infinity. So we pick option D, which says final image is at infinity. Which of the following statements about defects of vision is or are correct? So we'll then take a look at these three different statements, and then we'll pick out the ones that is or are correct and also identify the one that is or that are not correct. So the first statement says, for a long-sighted person, close objects appear blurred. Now, another name for long-sightedness is hypermetropia. Now, when a person has hypermetropia, it means that the person is unable to see objects that are close to the eye, but is able to see objects that are farther. So that's why it's called long-sightedness. The person can see something that is far from him, but things that are brought close will appear very much blurred. So that means statement 1 is correct. Now, the inverse of this would be for myopia or short-sightedness, which we see in statement 2. It says, for a short-sighted person, distant objects appear blurred. This is because they are only able to see things that are closer to the eye. But when things are far from the eye, it becomes blurred or they can't even see it at all. So this statement is also correct. Now the third statement says short sight is corrected by using a pair of converging lens. Now when it comes to correction of eye defects, for myopia, what is used to solve the myopia vision, that is short-sightedness, is the use of the concave lens. And concave lens is a divergent lens, not a converging lens. Convergent lens is the convex lens, and that is used to for the cases of long-sightedness or the hypermetropia. So in the case of this third statement here, where we mention convergent lens is supposed to be for long-sightedness, not short-sightedness. So that means this statement is wrong. So now we have only two statements that are correct. That is statement 1 and statement 2. And that is what we find in option D. So that means the correct answer to this question is D. In this question, we are asked the part of the human eye that does similar work as the diaphragm of a camera lens is the... Now, we have 4 options here. So what I'm going to do is I'm going to explain what each of these functions as to the part of the camera that also does similar functions. I did mention at the beginning of this video though that we can compare the human eye and the camera, and that each of them have their similarities and also their differences, just as much as there are some parts of the human eye and the parts of the camera that do the same function. So that is what this question is all about. But this time we have to identify the part of the human eye that does the same function as the diaphragm of a camera. So starting with option A, which is the ciliary muscle. Now what this does is that it contracts and expands to help you focus the image of an object that you are seeing. And the part of the camera that does that is the focusing mechanism of a camera. So that is not the function of a diaphragm. So that is out. Then B is the pupil. Now what the pupil does is that it either opens wide when there is less light or closes when there is a lot of light, just to limit the amount of light rays that gets into the retina. So, and the part of the camera that does the same thing is known as the aperture. Now you open the camera aperture when you want more light to come into the camera in cases where there is less lighting, and then you also close the aperture whenever there is a lot of lighting and you want to limit the amount of light that is getting into the camera. So you see, aperture and pupil, they perform the same function, but we are not looking for aperture, but we want diaphragm. Now that brings us to the iris, which is actually what controls the aperture in itself. And what controls that is the diaphragm of a camera. So the diaphragm of a camera will help you control the aperture, while for the iris, it controls the pupil's function. So that means iris is the same as aperture for a camera. Now before I then write this down as our answer, let's look at retina, which is the last option. Now the part of the camera that does the same function as the retina is the film or digital sensor. Now what they do is they record the image itself, right? So that's the exact thing that the retina does. It's the one that actually captures the image and sends it through the nerve endings to the brain. So it performs the same function as the film of a camera. So now that we've looked at the functions of each of these, we can now put down our answer, which is option C. The following are parts of the eye. So we have number 1, retina, 2 being pupil, and then 3 being the iris. Now the correct equivalent in the camera in same order are, now when we compare this to the camera, I didn't mention in the last question we answered that the retina does the same function as the film of a camera. The pupil does the same function as the aperture of a camera. And then the iris does the same function as the diaphragm of a camera. So this would be the correct order to put the answer. So film, aperture, then diaphragm. Now when we compare that to the options that we have, okay, we see that in option D where we have film, aperture, then diaphragm. So the correct answer is D. In this question, which says the instrument used to view the stars is the... I'll not just pick the answer, but I'll also tell you what each of the other instruments are used for. Because this question can be flipped about to answer for any of the options that are here. So let's just answer them all, just in case you find questions like that. So when we consider the prism binoculars, what it is used to do is to magnify images of objects on Earth Like when you go bird watching or when you go for sports games like that and you're in the gallery, you have to view something that is a bit far from you. With the prism binoculars, you're able to magnify such objects so that you can see them more clearly despite your distance from them. But when you consider the telescope, it is used to view even more distant objects such as what we call the celestial bodies, objects such as the moon, the stars, and other things like that. So for this question, the answer is telescope. But moving to the others, option C says film projector. This is used to project motion pictures. What it actually does is that there's a film strip that is placed there, and then the light beams through the strip, and then you use a lens to focus the image from that film onto a screen. That way, what you see in that film that is very small can then be projected to be a large image that can be viewed by a lot of audience, like what happens in the cinema. So they use the film projector in such cases. We also use it in cases of classroom teaching where something has to be displayed to the students. The projector will beam the image onto a screen so that the entire class can see what is being talked about. And then for the case of the microscope, we use that to enlarge images of very small objects, like when you want to view things like amoeba, things like the spirogyra colonies and things like that. We use microscope, which enables you to see greater details of very tiny objects. So now we've touched each of the functions of these four instruments as used in physics. But for this question, the correct answer is option B. In this question, it says the eyeball consists of a round, tough, white skin called, and then we have the following options. So let's highlight these options and then talk about what they do as well as describe them as best as we can. Now, when it comes to the sclerotic, another name for this is sclera. Right? And what this does is that it's the one that actually provides protection to the eye, and it is actually made of a white tough skin like that protects the eyeball. So the answer to this question is actually option A, which is sclera or the sclerotic. Now option B is the choroid coat, and it's actually behind the sclera, and it is the vessel that provides nutrients and blood to the eye. And then option C says optical fiber. Now the eye does not have what is called the optical fiber, but has what is called the optical nerve endings, which is actually what transmits message to the brain from the eye. So this is completely out of it. And option D is accommodation, which actually describes the ability of the eye lens to change its shape in order to focus the image of an object that is closer or that is far from the eye. So having looked at this, we can then be rest assured that no matter how the question goes, we should be able to answer questions that pertains to the sclera, to the choroid coat, and to accommodation, and also the optic nerve endings. But in this question, the answer is option A. Now, this question says, in a compound microscope, the objective and the eyepiece focal lengths are. Now, before I explain the answer, if you're yet to be subscribed to the channel, please, I would like you to take a moment to just click the subscribe button, because as many of you that really subscribe to the channel, what you're doing is you're helping us to be able to make more helpful content like this. So please click the subscribe button and also hit the notification bell icon so that you'll be notified every time we put out a new content. And also do not forget that whenever you have any question at all, perhaps whether it is about what we are doing presently or if it's about something you found while you were studying that you need more clarification on, feel free to drop such questions in the comment sections of our videos, and we will definitely attend to every of your comments. And also don't forget to share the video so that we can reach a wider range of audiences that are really in need of content like this. So please keep sharing, don't forget to subscribe, and always like the video. And to also practice even more, you can click the link in the description box to download the Exam Fun app, which is created with you in mind, because we want to ensure that your study time is filled with fun and not just a boring practice for you. So please download the app today, and I promise you, you're going to enjoy studying with the Exam Fun app. And even what's more interesting is that as you learn on the Exam Fun app, you also earn some money while you learn. So it makes it even a wholesome experience that pays you back in the end. So please ensure you click the link and download the app today. Thank you very much. Now, back to the question. We see that we are looking at the focal length of the objective lens and the eyepiece of a compound microscope. Now, the purpose of a compound microscope is to be able to create a really magnified image of tiny objects. So, for you to achieve this, you have to use really short wavelengths. So, the wavelength, I said wavelength, I mean the focal length rather. Really short focal length for the objective and the eyepiece of your compound microscope. So the answer to this question is option C. However, it's important I also mention this, that the focal length of the objective lens is shorter than the focal length of the eyepiece. This even further magnifies the image produced by the objective lens. So you see, it is both of them are short indeed, but the objective lens has a shorter focal length as compared to the eyepiece. Where the objective lens is having focal length of about 1 centimeter to about 2.5 centimeters, the eyepiece has from 2.5 to about 5 centimeters for focal length. So you see that the eyepiece has a longer focal length as compared to the objective lens. But generally, both of them have short focal length. So we stick with our answer, which is option C. If the linear magnification of the objective and eyepiece convex lenses of a compound microscope are 4 and 7 respectively, calculate the angular magnification of the microscope. Now, when you're asked to solve problems like this, you should know that angular magnification, when you are looking at two lenses, is the product of the individual linear magnification of the lenses. So basically, angular magnification M equals M1 multiplied by M2. So what we have there is M1, which is 4, multiplied by M2, which is 7. And then the angular magnification is therefore 4 times 7, which gives us 28. So the correct option is D. Now, in this question, it says the terrestrial telescope has one extra lens more than the astronomical telescope, and we're asked the extra lens is 4. Now, when you compare a terrestrial telescope to an astronomical telescope, they have a number of differences. Now, one of them is that the terrestrial telescope, as the word terrestrial implies, it means it is used to view objects that are on Earth. Like, for example, if you're at sea and you're trying to view a distant ship that is approaching, like those of you that like pirate movies, you often see them use the terrestrial telescope to find objects that are approaching them, such as enemy ships and the likes. That's a terrestrial telescope, while for the astronomical telescope is used to view celestial bodies like the stars, the moon, and other objects that are in space. Now, another difference is that when you look at the terrestrial telescope, it has a wider view range, while the astronomical has a narrower view range. And then the other difference again, which is what this question is talking about, is the fact that a terrestrial telescope has an extra lens, but the astronomical telescope does not have an extra lens. Now, the function of that extra lens in the terrestrial telescope is what this question is about. Now, that lens is there in order to invert the already inverted image produced by the telescope. So originally the telescope will produce an inverted image. So the addition of another lens into that telescope reinverts it. So what is supposed to now be inverted before will now appear upright. So what it does is to make the image upright. So that is why it is often called the uprighting lens. So to answer this question, the function of that extra lens in the terrestrial telescope is for the erection of image. So we go with that option D. A certain far-sighted person cannot see objects that are closer to the eye than 50 centimeters clearly. So determine the power of the converging lens, which will enable him to see at 25 centimeters. So let's see what we have in this question. Now, in this case here, we see that the object that we want to view is at 25 centimeters. The image will be created behind, so it will be minus 50 centimeters. So we do not know what F is. F is unknown, the power is unknown. But we know that power equals 1 over F, which is the focal length. So first, let's find the focal length, and then that way we can get the power of the lens. So to get focal length, we use lens formula. 1 over F equals 1 over U plus 1 over V. Now what this implies is that 1 over F is 1 over U is 25 plus 1 over negative 50. This affects this and it becomes minus sign. So now 1 over F equals, now when we take LCM, that will be 50, and then 25 here, that will be 2. Then because of this plus and minus, we have minus, and then this will be 1. So what we have here is 1 over 50. And when you flip this, it implies that F equals 50 centimeters. Now let's find the power. Now I did mention something in one of our videos that when you are looking for the power of a lens, you always have to convert your focal length in meters. You have to write it in meters. So since this is not in the correct SI unit, we're going to put this as 0.5 meters. So the power of the lens is therefore 1 over 0.5. And this is going to give us 2.0 diopters. Okay, and when we look at the options, we have 0.06, 0.02, 0.03, 0.04, and then no option is correct. So since we can't find 2.0 in the option, then we go with the option E, which says no option is correct. This question says, when the human eye loses its power of accommodation, the defect is known as. Now, before I go on to answer this, let me remind you that if you're yet to be subscribed to the channel, please take a moment of your time to just click the subscribe button. It's only going to take a second. You just need to click the button. That way you'll be helping us to be able to continue to make more helpful videos like this. And also you can hit the subscribe button. Aside hitting the subscribe button, you can also click the notification bell icon so that you get alerted every time we put out a new content. And we urge you to always like the videos as well as share them so that we can reach a wide range of audiences. And if you have any question at all that you need our help with, please drop it in the comment section. We will definitely attend to every one of your question. So now back to this particular question we're answering. We are looking at when the eye loses its power of accommodation, but beyond that, I just want to look at each of these eye defects again and then touch on them, what they really are and how you can correct them. Then we go on to answer this question. Now option A says short-sightedness. Now another name for short-sightedness is myopia. Now this is when the eye is unable to focus objects that are far away from it. Okay, it's only able to see things that are closer, cannot see things that are farther from it. So to correct this, we use the diverging lens. So another name for diverging is concave lens. Okay, and then presbyopia is something that comes with age. And that is when the eye is unable to, as in the lens is unable to focus on, to change its shape to focus on far objects or close objects again. It cannot stretch again. It's not as elastic as it used to be anymore. And that's basically the eye losing its accommodation, right? So in this case, the lens that is used to correct this is the progressive lens or bifocal lens. Okay. Now, astigmatism is actually a situation where the lens has an irregular curve. The cornea rather has an irregular curve. That way, it makes it impossible for the eye to see clearly with objects that are even within the normal near points or far points of the eye. Now, to correct this, we use cylindrical lenses. And then long-sightedness, also known as hypermetropia. Can be corrected using converging lens or convex. So having touched on all the different eye effects, we can then pick our answer, which is presbyopia. Now, even though presbyopia comes with age, it is also possible to see someone who is younger have presbyopia. So it is not only limited to older people, but it is when the eye loses its power of accommodation. So the answer here is option B. An observer with normal eyes view an object with a magnifying glass of focal length 5 centimeters. The angular magnification is, now to find angular magnification in this situation, now you have to take note that the near sight of a man is 25 centimeters, when near point rather of a normal human eye is 25 centimeters, while far point is at infinity. So in this case, we're going to use the near point. That's why you're given D equals 25 centimeters in the hint box. Now, the equation to find angular magnification using this would be 1 plus D over F. So this will give us 1 plus, now D is 25 centimeters divided by F, which is 5 centimeters. So centimeter cancels centimeters. What we have is that the angular magnification is 1 plus 5 in 25, that is 5. So our answer is 6. So the angular magnification is 6, which is in option D. In the microscope, the eyepiece lens merely acts as, now the microscope has two major lenses, the objective lens and the eyepiece lens. Now, the function of the objective lens is to gather light from the light source provided to the specimen being viewed and then produce a real and magnified image of that object. Now, that real and magnified image can be in the order of 4x, 10x, 100x, which sometimes you see some microscope have about 3 to 4 of such lens that can be rotated, right? So, but after that has been produced, remember the objective is producing a real magnified image. But the eyepiece now will then further magnify what has been produced by the objective lens. So both of them magnify. But the function of the eyepiece is to further magnify what has been produced by the objective lens. So it's going to be acting as a magnifier. So we put down option D. The instrument used by designers to obtain different color pattern is called. Now let's look at this instrument and what they are used to do and then go on to pick the correct answer. Now option A is the periscope. Now the periscope is an instrument that is used to view around or over obstacles. Like in the case of submarines, they can use it to view objects that are above the sea level even while the submarine is deep under the sea. Now, the instrument known as the sextant, which is in option B, is used to measure the angle between two celestial bodies. Like if you are looking for the angles between two planets or two stars, you would use a sextant. Now, the episcope is used to project the image of an opaque object onto a screen by beaming a light to it, then casting that image onto a screen. And then finally, the kaleidoscope is used to shine light either by reflections of light or colored pieces to create a colorful pattern, and is often used in designing. So as far as this question goes, since we are asked the one that is used to obtain different color patterns and is used by designers, of all these 4 options, the only one that produces color patterns is the kaleidoscope. So the correct answer is option D. The plane mirrors in a kaleidoscope are usually placed. Now, when we consider a kaleidoscope, it consists of mirrors that are placed at 60-degree angle to each other. This is to enable it to produce a symmetrical pattern of colors that makes the design it creates even more appealing to the eyes. So the answer to this question is in option A. However, let me also mention that in the case of a periscope, the mirrors in the periscope are placed at a 45-degree angle to each other. So if this question were about periscope, we would have gone for option D, which says that at an angle of 45. But because this is kaleidoscope, it is at 60 degrees. And don't forget that the reason for that is so that it will produce symmetrical pattern of colors that even makes the design appealing to the eyes. Now, if you want to practice more with questions like this, you can always download the Exam Fun app. The link to download is added to the description box of this video. kindly click the link and download the app. I promise you, you have not studied the way you would do when you start using the exam fund app, because it is created in a way that it infuses fun into your learning time. And what makes it even more rewarding is the fact that even as you use the app, you can also earn money with it. So please download the app today and have fun while you learn. Please do not forget also to hit the subscribe button if you haven't done that already, and also click the notification bell icon so that you get alerted every time we put out a new content. And also don't forget to share the videos. It is our goal to reach many audience that are in need of helpful content like this. So please help us achieve this goal by sharing our videos to your contact list, and also urging them to also subscribe to the channels and also share to their own contact as well. And if you have any question at all, perhaps it's on what we are doing, or perhaps during your study time you came across a question that you would like our help with, please drop it in the comment section and we'll definitely attend to all of your comments. Thank you all so very much for being part of the series so far. I'll see you in the next video. Thank you very much.